Hello friends, welcome again. In this video, I'll be explaining you the nature of roots which can be predicted by observing the behavior of the discriminant. My name is Yogeshwar Singh and let's start with the analysis of discriminant. Nature of roots of a quadratic equation. This itself is a very important topic in quadratic equations. When we talk about the nature of roots, it means that this x is equal to minus b plus minus root over b square minus 4ac upon 2a. This is the root of the equation. Here are two roots, alpha and beta. Now we will be talking about the nature of these roots. Means without actually solving the equation, we will try to predict the equation's roots and then try to solve different type of questions. Now here, as we know that ax square plus bx plus c is equal to 0 is a quadratic equation. Here basic conditions are a, b, c are all constants and a is not equal to 0, because if a is equal to 0 then this equation will become a linear equation, then this all analysis will be as per the linear equation. So for this equation to be quadratic, a must not be equal to 0 and here only variable involved is x. A, b, c are all constants. So if you observe this solved value of x, it involves minus b plus minus root over b square minus 4ac upon 2a. This number depends on the values of a, b and c. So we will try to analyze this, that depending on the values of a, b and c, when we will get which type of root. So here the main thing which decides the nature of these roots is the discriminant, that is b square minus 4ac. b square minus 4ac is the only term which is under root. A, b, c could be anything, it is just minus b by 2a. It is not creating any problems. The problem is a root over b square minus 4ac. This root has a inherent property that if we put a negative number under root, then we will get a imaginary number. So let's try to analyze this. First we will consider the case of real numbers, that is a, b, c, that is the coefficients of the quadratic equation. All of them are real numbers. So we see that if a, b, c are real numbers, then b square minus 4ac will also be a real number. But this number could be positive, negative or 0. Depending on this value, this root can be either defined or will go to imaginary, or it will not play any role in the root. So first case we will consider is if d is greater than 0, that is if this term is greater than 0, then this root is defined and we will get two real numbers. So minus b plus minus root d upon 2a will give you two distinct real roots. For example, x square minus 5x plus 6 is equal to 0. Here the discriminant is 1, that is b square 25 minus 4 times 6, that is 24. 25 minus 24 is equal to 1. So x is equal to, on solving you get 2 or 3. If d is equal to 0, then this number vanishes, then x is equal to minus b by 2a. So plus minus 0 will not play any role. So value of x will be minus b by 2a, means both the roots are same. For example, x square minus 4x plus 4 is equal to 0. Here discriminant you see b square, that is 4 4 is 16 minus 4 times 4 16 is equal to 0. The roots are, after solving you get, this is x minus 2 whole square, x is equal to 2 comma 2. Here we will not say that the root of this equation is only one root 2. As per the definition, a equation of degree n has exactly n roots. So this equation has two roots, but both of them are equal, that is 2 is a repeated root. This is a important point, you have to remember this, that a quadratic has two repeated roots, then you have to mention both the roots. Now the third part is if d is less than 0, that is root over b square minus 4ac is negative. If this quantity under the root is negative, then it is not defined, it is an imaginary number, then you will have to use iota. So the roots of this type of equation which has a negative discriminant will be complex or imaginary, that is minus b plus minus something times I by 2a. For example, if we try to find out the roots of equation x square plus 4 plus x plus 1 equal to 0, here you see the discriminant is b square 1 minus 4 which is equal to minus 3. Discriminant is minus 3. So the values of x are imaginary, that is minus 1 plus minus root 3 times I by 2. This under root minus 3 is root 3 I. So the roots are complex or imaginary. Here one important thing you have to keep in mind, that imaginary roots always occur in conjugate pair, minus 1 plus minus root 3i. As we all know that a plus ib and a minus ib are conjugate pair of each other, provided a, b are real numbers. So minus 1 plus minus root 3i, that is if one root is minus 1 plus root 3i, then the other root will be minus 1 minus root 3i. That is, if one root is given to you and a, b, c are real, then you can say that the other root will be conjugate of the given root. Let's do some conceptual questions. These are very important points to remember. First is, you have to state whether the given statement is true or false. The first statement is, if roots are imaginary, then they will occur in conjugate pair. Is it necessary? No, this is false, because if roots are imaginary, then they will occur in conjugate pair if and only if a, b, c are real. If a, b, c are itself complex, then you cannot say this statement. This conjugate pair concept was developed only for a, b, c real. Remember this thing. The next question is, if one root of this equation ax square plus bx plus c is equal to 0, it is given here that ABC belongs to R is p plus I cube, then the other root will be p minus I cube. Is it true? Think. No. This is also false, because if p plus iq is one number, this looks a complex number, that is p plus iq, then the other root will be p minus iq, conjugate of this. But what happens if q itself is a complex number, that is suppose p plus I times 3i, I times 3i, that is 3i square, that is p minus 3. This is not a complex number. So we have to make sure that this is the imaginary part of the complex number after solving. It's not that p plus iq and this itself turns out to be a real number afterwards on solving. So you have to be very careful. If p and q are real numbers, then only you will say that other root will be p minus iq. If p or q, any one of them is a complex number, then this cannot be said. Now let's see one more question. Question is, find the quadratic with real coefficients whose one root is 2 minus 3i. Here it is given that you have to find a quadratic with real coefficients, means ABC will be real. So if the root is given is 2 minus 3i, then the other root will be what? 2 plus 3i. As per the concept, if ABC are real, then the complex roots occur in conjugate pair. So if one root is 2 minus 3i, the other will be 2 plus 3i. So you add these two roots, get sum of the roots as 4. Product of the roots is 2 plus 3i into 2 minus 3i, that is a plus b into a minus b. 4 minus of 9i square. I square is minus 1, so minus minus becomes plus. 4 plus 9, that is 13. So equation becomes x square minus 4x plus 13. That is x square minus sum of roots times x plus product of roots. The second method is also available. What we do, we assume that x is equal to 2 minus 3i. Since x is a this 2 minus 3i is the root of this quadratic equation, the x is equal to 2 minus 3i can be assumed very safely. Now We know that we have to find the equation of second degree in real coefficients. Means first you have to get x square, second you have to get rid of this I. So what we do, we transfer this 2 to the other side, x minus 2 is equal to minus 3i. Now you square it. When you square it, this I will vanish and become minus 1. So you will get x square minus 4x plus 4 is equal to minus 9. Transfer this minus 9 to this side, you will get x square minus 4x plus 13 is equal to 0. Both the answers are same. You can use any one of these two methods, but you have to make sure that the coefficients required in the equation are real, then only you will apply this method. Now let us see what happens if a, B, C are rational numbers. This is a subset of the previous part. Please ignore this plus minus root 3, it will be coming later. If A, B, C are rational, then this is a subset of the previous part, because if A, B, C are rational, then they are subset of real numbers. So what we do here, we will discuss the behavior of discriminant for only positive or 0, because if it is negative, then whether it is rational or real, you will get a complex number. So roots will be imaginary if discriminant is less than 0. If discriminant is positive and is a perfect square, if the quantity under the root is a perfect square, then the roots are rational. That root will vanish, you will get a rational number outside. You solve, you will get two values of x, both are rational. For example, 12x square plus 7x plus 1 is equal to 0. On here you will see that discriminant is b square, that is 49, minus 4 into 12, that is 49 minus 48, that is equal to 1. So on solving you get x is equal to minus 1 by 3 comma minus 1 by 4. Here both the roots are rational because discriminant is a perfect square. It could be 4, 49, 9, 25, anything. If the discriminant is a perfect square, you will get a rational roots. They will be distinct, but rational roots. Now, if the discriminant is positive but is not a perfect square, if it is not a perfect square, then the quantity under the root will remain under the root. You will get an irrational number. For example, root 3, root 2, root 5, something like this. So this root will remain there and your result will be a irrational number. So the roots in this case will be irrational, and as in the case of real numbers, imaginary roots were occurring in conjugate pair. If A, B, C are rational numbers, then irrational roots will occur in conjugate pair. For example, x square minus 4x plus 1 equal to 0. Here the value of discriminant is b square 16 minus 4, that is 12. So the roots will be x is equal to 2 plus minus root 3. This irrational roots, if coefficients are rational, will occur in conjugate pair. Remember, this is very important. Now let us try one question. If you are given that a quadratic with a rational coefficient has one root, root 2 minus 1, then you have to find the root. My friends, remember one thing, that this is a irrational number, no doubt, root 2, but if you are going to write the conjugate of this number as root 2 plus 1, then you are wrong. Conjugate is the, in writing the conjugate, we change the sign of the irrational number, or if it is an imaginary number, to write the conjugate, we change the sign of the imaginary part, not the real part. So the conjugate of this number will be minus 1 minus root 2. So since the coefficients are rational, then imaginary roots will occur in conjugate pairs. So if one root is minus 1 plus root 2, then the other root will be minus 1 minus root 2. On adding these two, we get root 2 gets cancelled, the sum of roots is minus 2, and product of roots is a square 1, b square 2, a square minus b square, which we get 1 minus 2 is equal to minus 1. So the equation is x square plus 2x minus 1. The alternative method is same as the previous one. What we do, we assume that x is equal to root 2 minus 1. We need rational coefficients and the equation in second degree. What we do, we square to get rid of this root sign as well as we get a second degree equation. So, x, you transfer this minus 1 to the other side, you get x plus 1 is equal to root 2 square, you get x square plus 2x plus 1 is equal to 2, or x square plus 2x minus 1 is equal to 0. In both the cases, the answer is same. This is your answer. Now, let us do some good questions. First question is, if a plus b plus c is equal to 0, then you have to find the nature of roots of the equation 4ax square plus 3bx plus 2c equal to 0. A, B, C are real numbers and a is not equal to 0. This is the quadratic equation. Remember, the coefficients are 4a, 3b, 2c. Equation is a quadratic equation in x. You have to predict the nature of the roots. So, first, if you want to try it, you can pause the video, try the question and then look at the solution. Let us analyze the question first. If we need to predict the roots of the equation, then what we do? We need to predict the nature of its discriminant. How is this discriminant behaving? If we are able to prove that the discriminant is less than 0, then we can say that the roots will be imaginary. If the discriminant is 0, then we will say that the roots are real and equal. If the discriminant is positive, then we will say that it has discriminant is positive, then the roots will be real and distinct. So, you have to find a relation to decide whether the discriminant is positive, 0 or negative. What we do? We find the discriminant first. D is equal to 3b whole square minus 4 times 2c into 4a, that is 9b square minus 32ac. But this here, this is, we know, is a positive number, but this number could be anything. Depending on the sign of a and c, this could result in a positive number or a negative number. So, till now we cannot say anything about the sign of the discriminant. Now, we have been given one more relation, a plus b plus c is equal to 0. What we do? We substitute the value of b from here, that is minus a minus c, in place of b. Square it, you get 9a square plus 9c square plus 18ac. Remember, a square plus c square plus 2ac, this minus sign, when you take it out, it gets squared and becomes positive. So, you get 9a square plus 9c square plus 18ac is equal to, sorry, minus 32ac, which is equivalent to 9a square plus 9c square minus 14ac. Here we can predict the sign of 9a square, which is a positive number, 9c square is a positive number, but this 14ac is still a problem. We cannot predict the sign of this 14ac till now. So, what to do now? What we do? We try to use this number. We see that AC is here, A square is here, C square is here. We try to take out the relevant items from here, combine it with 4AC and make it a perfect square. So, what we do? We take 7A square from 9A square, 7C square minus 14AC. The remaining 2A square, 2AC square, this is positive, this is not creating any problem. The problem is only minus 14AC. From here you take out 7 common, you get 7 times a square plus c squared minus 2ac plus 2a square plus 2c square. Now, you observe this expression. This is what? A minus c whole square. So, now we can write it as 7 times a minus c whole square plus 2a square plus 2c square. Here a minus c whole square is a perfect square, a square is a square, c square is a, all of them are positive multiplied by a positive constant. So, this number is positive, positive, positive. So, all of them are either greater than or equal to 0. So, from till now we can predict that the discriminant must be greater than or equal to 0, but we are also given that this a is not equal to 0. If a is not equal to 0, means this number is not 0, this is strictly greater than 0. So, even if this becomes 0, this becomes 0, this is a positive number. So, the entire sum will always be greater than 0, strictly positive. So, if the discriminant of this quadratic is strictly positive, means the D is always greater than 0 and hence roots are real and distinct. Now, let us try one more question. if x square plus 2 times a plus b plus c times x plus 3 times ab plus bc plus ca is equal to 0 is a perfect square, if this quadratic is a perfect square, then you have to find a relation between a, b and c. Options are a is equal to b is equal to c, b a is equal to minus b is equal to minus c, c a is equal to 2b is equal to 4c. Option D, not means none of these. You pause the video, try the question and then look at the solution. For solving this question, if we want this number to be a perfect square, that is of the type x minus 2 whole square, so we know that this equation has a repeated roots, then only it will be of the form x minus alpha whole square. So, x is equal to alpha comma alpha. So, for repeated roots, this equation must have a discriminant equal to 0. Now, what we do? We write the discriminant of this equation. So, b square, that is 4 times a plus b plus c whole square, minus 4 times 3 into ab plus bc plus ca into 1 is equal to 0. You square this, a plus b plus c whole square is a square plus b square plus c square plus 2ab plus 2bc plus 2ca minus 3 times ab plus bc plus ca is equal to 0. Now, this 4 gets cancelled, it goes to the RHS. We are left with a square plus b square plus c square plus 2ab minus 3ab is minus ab plus 2bc minus 3bc is minus bc plus 2ca minus 3ca is minus ca equal to 0. You observe this relation. Here we cannot find any relation between a, b and c. So, we need to do some manipulations. So, what we do, we see that AB is there. If it is 2AB, we can make it A minus B whole square. If it is 2BC, we can make it B minus C whole square. 2CA, then we can make it C minus A whole square. So, what we do, we multiply this entire equation by 2, A square plus B square minus 2AB plus B square plus C square minus 2BC plus A square plus C square minus 2AC is equal to 0. So, if you combine this, A plus square plus B square plus minus 2AB, B square plus C square minus 2BC and A square plus C square minus 2AC, you observe this is a perfect square, A minus B whole square, this is a perfect square, B minus C whole square, and this is a perfect square, C minus A whole square. So, this number is greater than or equal to 0, this number is greater than or equal to 0, and this number is also greater than or equal to 0. If sum of 3 positive numbers is 0, if sum of 3 positive numbers is 0, then what is the possibility? This can happen only if all of them are equal to 0. So, A minus B is equal to 0, B minus C is equal to 0, C minus A is equal to 0. Here you get A is equal to B, here you get B is equal to C, here you get C is equal to A. So, A is equal to B is equal to C. This completes the analysis of discriminant and nature of roots. Thank you very much for watching. Please do subscribe to my channel YLC, that is your learning curve. Remember, practice makes someone perfect and there is no substitute for hard work. Thank you very much.